Greetings, students. Today we're going to look at Unit 8, which is on applications of integration. Unit 8 is referring to the fact that this is the 8th unit in the curriculum according to the AP Central people. I'm going to share my PowerPoint with you, and if you'd like a copy of this, it's on Canvas, as always. So we're going to do some examples. Our first example is to find the average value of a function. So this function is f of x equals x ln of x, and we're looking at from the interval from 1 to e. So my pen going here. So we're basically trying to find the average value from this starting point to this ending point. So if we look at the curve between here, we want to know roughly what the average is. So it's, this is a little bit less than 3, and then this guy down here is at 0. So my guess is the average is somewhere around, well, between 1 and 2. So let's see how that works. So to find the average value, we are going to use the formula 1 over b minus a integral from a to b of our function, in this case with respect to x. So in this particular answer, we're going to do 1 over e minus 1 integral from 1 to e. Our function is x ln of x dx, and then we would just compute. You can compute this one by hand. I went ahead and used my calculator just to speed this particular example up, and it turns out to be 1.221. So the average value of the function, the lowest value of the function on that interval was 0. The highest value here looks like it's 2 point whatever. The average value of that function is 1.221. So there's our first example. All right, the next example I want to talk about here is the area between two curves. So we have the curve f of x, which is the red curve here, it's the parabolic curve. And then we have the blue curve, which is a linear function 4x plus 16. We want to find the area between these two curves. To find the area between these two curves, first thing we're going to have to do is we're going to figure out where they intersect. Where do these guys intersect? Now, how you would do that is you would just simply solve the equation 4x plus 16 equals 2x squared plus 10. And it turns out when you solve this equation that you'll get two answers. One of those answers is x equals -1. The other answer turns out to be x equals 3. I'm not going to go through the algebra. So this x value here is -1. This x value here is 3. You also need to be able to figure out what the top function is, which since I've got the graph, it's really easy to see that. If they don't give you the graph, I highly encourage you to make a sketch of it so that you can get those two things situated. So now we're ready to compute. So to find this area, we're simply going to integrate from -1 to 3. We're going to do f of x minus g of x. That's not correct. I did that wrong. But the good news is I can fix that, I think. Let's see if I can remember how to erase. We need the top function first. So I think I did it the wrong way. So we'll fix that. So the top function is actually the g of x. So we need to do the g of x function first, and then minus the bottom function, which is f of x in this case, dx. And again, to speed this process up, I used a calculator, and the area here turns out to be roughly 21.333. Okay. The next example involves volumes of revolution. So we have two curves here. We've got f of x, which is the red curve here. And then we have g of x, which is, again, another linear equation. It's a linear equation with a slope of 1/2. Now notice we're rotating this guy around the y-axis. So it's rotating around the y-axis. So guess what that means? That means all of these things need to be written in terms of y. We'll get to that in a second. But to find this volume, we're going to remember the pi r squared formula. Okay, and by the way, we are also going to need to do the washer method here because we're going to have missing space that we're not going to include in our volume. Okay, so first of all, we need to convert this into y. So this is y equals the third root of x, which is equivalent to y to the third equals x. And then the second guy here, g of x, which again could be written as y equals x over 4, could be rewritten as 4y equals x. So now I have everything written in terms of x. We also need to find this intersection point here, and I'm just going to go ahead and tell you that it's at 8, 2. Now we're going to need the 2 because remember we're going to integrate with respect to the y-axis. So to get our answer here, the volume is going to be pi integral from 0 to 2. Now we've got to do the function to the right. Now normally we talk about being top minus bottom. Here we're going to do right minus left. So the right function is this 4y. So we're going to do 4y squared minus the left function, which is this y cubed squared, and we're doing this with respect to y. The answer here, once we compute, is 76.595. So that's our approximate answer to 3 decimal places. Okay, and we've got one more example here. The last example is for BC students only. So if you're an AB student, you can watch if you are interested in seeing how to do something called the arc length. Otherwise, you can just leave. BC students, we're going to actually go ahead and calculate the arc length here. So here's our function. I've got a graph of it. This is, I just got creative and tried to use different letters. The function's name is t, and the variable, the dependent variable there is beta. So we've got t of b is equal to 4 beta to the 1.5 power, and we're talking about on the interval from 0 to 4. So we're basically saying, what is the length of this segment, right, or this curve, starting from 0 all the way to 4? So the formula that we're going to use, we use S for arc length, and don't ask me why we use S. We're going to do this, we're going to integrate from A to B, the square root of 1 plus, and we're going to find the derivative of the function we're dealing with, squared dx. So this is the formula, and if you don't remember that formula, I highly encourage you to remember it, because if they ask you an arc length question on the exam and you don't remember it, you're probably not going to get it. Okay, so arc length here is going to be equal to integral from 0 to 4 square root of 1 plus. Now I got to figure out what f prime is here, and f prime's not very difficult. So when I take 4 times 1.5, I'm going to get 6 beta, and then you got to subtract 1 from the exponent, so that's just going to be 0.5 exponent, and we're going to square that dx. And at this point, I'm going to plug this into my calculator and let it do the work, because we're getting past 8 minutes, and that's going to be 32.315. That is the arc length, which kind of makes sense. One thing you could do to kind of check that answer is imagine if we were to draw a right triangle here. If you were to draw a right triangle, this length down here would be 4, and this height here is roughly around 30, and you'll see 30 roughly. So if I was to calculate that segment's length, it gives you kind of an idea that this answer should be about right, because this answer I think turned out to be about 31 or something like that. But that's it for my presentation for review of applications of integration.